Here you've been given the derivative and the second derivative in a table. And the first thing you're asked, part A, where, if anywhere, does the function g have a local max? Justify your answer. Well, I'm going to justify my answer first before I find it. A max will exist where the derivative changes from positive to negative. So notice we have a positive and then a negative. So even though this is undefined, there must be a max at x equals 4. I've earned full points on part A. What else does this table mean? Well, if the derivative is positive, that means the function is increasing, and a negative derivative means the function is decreasing, giving the max. And then I have zero slope, and then I have negative slope. So also that must mean I have a plateau at x equals 6. Now let's look at the second derivative. A positive second derivative means I'm concave up, or my function must be shaped like this. Undefined, and more positive derivative, so I'm still concave up. And then a zero slope and negative, meaning I go concave down. So now I can put everything together. Also, additionally, g of 1 equals negative 4. So I'm going to start my sketch here, and I'm going to increase concave up to a max at 4. Increase concave up to a max, and this max is cusped because my slope is undefined. Why isn't it an asymptote? Because we were told we're continuous from 1 to 9. So now I decrease with also concave up slope. That's what this piece of information is telling me. I decrease until 6, where I get to my plateau point. So I'm going to redraw this and level it off even more to make sure I really have zero slope. Concave down, concave up, but decreasing to zero slope, where I have my cusp and also my point of inflection, because my concavity changed from up to down. And now I'll draw concave down until the end. Here we had a max and a cusp. Here we have a point of inflection, not a cusp, but a plateau. Concave up, increasing, concave up, decreasing, more decreasing, concave down. That's how we take every piece of information from the table.